Good afternoon. My name is Sibel Schapner. I'm the program manager for the Advanced Sensor Instrumentation program. And I'm going to tell you a little bit about the program and the topics we have under this solicitation. So the vision for the Advanced Sensor Instrumentation program is to develop new sensors and instrumentation to address technology gaps for monitoring and controlling reactors and fuel cycle facilities. So we have three goals to do this. The first one is to support the DOE R&D programs with INC capabilities that they need for the reactor fuel cycle deployment. The second goal is to provide new innovative measuring and control capabilities. And the third one is to help address R&D needs so that they can be successful deployed of these new technologies. And that includes focusing demonstration on advanced technologies to provide science-level evidence for regulatory acceptance. Here in the slide, you can see the cover of our latest annual summary. And this contains like one page on the current ASI project, so that will give you an idea of what projects we're doing, and it's available on our website. So just to show how our research is organized, we have 4 areas. The advanced sensors to develop a fundamental understanding of sensors performance and to improve physical measurements accuracy and reduce uncertainty. The second area is digital monitoring controls to provide increase in control systems performance and self-calibration capability. Third area is nuclear plant communication, where we're looking for advanced communication technologies that support greater data generation and transmission demands while maintaining reliability, resilience, and data security. The last area is advanced concepts of operation to develop and test higher integral control system architectures where new human and system interaction is defined. Since we're a cross-cutting program, our goal is to support at least 2 or more of the DOE R&D programs listed on your right. And for this year's solicitations, we will be requesting proposals in the second area, which is digital monitoring control. And we have 3 subtopics under NEET-2, which I'll cover next. So the first subtopic is looking for state-of-the-art controls technology that can improve system performance, reliability, and economics. The goal is to improve system performance by removing control loops that add transmission, processing, and actuation time to current process control approaches in monitoring and controlling a component or a system. We're looking for applications that describe how the research will advance the state of the art and how it could improve the industry. We want testing and demonstration of the integrated systems, including a description of the system metrics and anticipating systems performance improvements. Examples of these include new types of digital technologies that are beyond what can be accomplished today by either conventional analog technologies or existing digital systems. For example, more resilient systems that anticipate the behavior of plant systems and react accordingly to manage system performance can avoid disturbances that result from systems that are designed to operate only at steady-state output. Physics and model-based control systems may be appropriate for some systems that can be modeled and managed more efficiently by advanced model-based control technologies. Advanced control rooms' fully digital systems should include seamless integration of displays and control technologies with operation techniques to manage input across systems. Streamlining and simplifying the design process for safety and non-safety related systems should afford improvements in maintenance, operation, and long-term costs of managing the resulting collection of technologies in the control room. It should also result in improved reliability and operation in the control room, including staffing efficiencies. So for the second stopping if I can get my notes right. Um, we're looking for proposals on big data analytics and applications for monitoring nuclear power plants operations and controls. We are interested in the ability to analyze and characterize data critical to nuclear energy applications. So analytics to understand how the current environmental conditions affect the plant operation. For example, new analytical capabilities to manage large quantities of data from operational assets and plant components from real-time plant operation. This could be different types of data and components with a common goal of understanding the underlying performance and performance implications in real time. And application to recommend changes in identified areas to make economics and maintenance improvements for nuclear industry. Proposals in this area should also consider the challenge of scaling techniques proposed beyond a particular problem being considered to the system context or broader context of the plant and how the proposed analytic tools and the techniques can be used by plant owners or operators to make immediate as well as long-term asset management decisions. Collaborations with utilities for input and testing may be beneficial in this area. And the third topic is looking for advanced sensors and instrumentation specifically designed for data generation. Successful design needs to be qualified for deployment in nuclear applications and support data communication. In order for some of the big data analytics vision to be achieved, it is more likely that new types of data will be needed for a variety of new sources in operating nuclear plants. This is likely to necessitate new types of sensors for sensing, detecting, and monitoring a measured parameter or a piece of equipment or plant component that is part of the big data analytics data generation scheme. Some of the challenges to deploying new sensors today include the need for wiring and cable for both power and communication, the size, cost, and longevity of existing sensors in nuclear service environments, or the quality and precision of sense parameters from existing sensors. This proposal area will support research into new types of sensors, including multimodal or multi-parameter sensors that can be easily deployed with an emphasis on cost effectiveness to achieve the goals of data analytics for improving plant efficiency and safety. Now, switching areas in the solicitation, under the nuclear science user facilities work scopes, all applications accepted will be for projects coupling R&D with NSUF access. The one under my area is listed as NSUF 1.1 topic, and we're looking for proposals in two areas. Advanced materials for sensors, which provides an opportunity to test any materials that are proposed for advanced sensors for survivability and performance in nuclear environment. So please provide a description of the materials, what irradiation and post-irradiation examination are needed, and how these materials will benefit new sensors and applications. The second area is advanced sensors. This provides an opportunity to test advanced sensors and associated instrumentation for nuclear energy application. Again, please provide a description of the sensor, what irradiation and post-irradiation are needed, and the purpose and application of this sensor. Please note that this is an opportunity to test your developed materials or sensors in an irradiated environment and document your results. It does not support new R&D. So in conclusion, some expectations for this FOA. As you plan your proposal, I want to stress out that we're looking for advanced INC technologies that will support reactor and fuel cycle development and deployment, improve economics and safety, demonstration of proposed technologies in a setting that represents the nuclear power industry, and innovative and revolutionary cross-cutting technologies that can be applied to multiple reactor designs and fuel cycle concepts. Here you have our contact information. My technical lead is Bruce Halber. He'll be on the line to help us answer any questions. Thank you.
Okay, we'll take questions through the question box on the GoToWebinar application. And Bruce, I've unmuted your phone, but I think that you need to put your audio pin in so it will recognize who you are. Bruce, it looks like you've muted yourself instead of needing an audio pin. Oh, there, Bruce, are you there? Okay. I think we're ready to go. We'll start with a question for NSUF 1.2.
Okay.
How much can be proposed to support the irradiation costs?
How much can be supported?
How much NSUF support can you request for the irradiation cost?
I'm not sure about the NSUF part, but the portion that we put is a 1.5 million? Up to 1.5 million, it says. I was going to say for our portion, it's about 500K for.
500K for the R&D.
Yeah.
1.5 million for irradiation only.
Okay.
4 million if you do irradiation and PIE. If you need a beam line or PIE, 750K.
Okay, here, we'll say that again.
Yeah, please.
The R&D portion of NSUF can be up to 500K. If you need an accompanying irradiation, it's up to 1.5 million. If you need accompanying irradiation and PIE, that's up to 4 million. And if you need access to a beam line or PIE, that's 750,000.
Okay, thank you.
What types of sensors would be of interest?
Like I said, for this solicitation, we're looking for sensors that will help with the I guess the plant control and data analytic applications. Does that answer the question? Bruce, you want to expand on that?
Sure. Sensors that can help to monitor active equipment or whatever your proposal addresses. So if you're proposing to address active equipment, or if you're proposing sensors for structural health monitoring, then the sensors that are proposed to support your monitoring application.
What are the differences between NEET 2.2 and RC5?
What is RC5? I don't remember.
NEET 2.2, RC5 is focusing on existing light water reactors, whereas NEET 2.2 is very broad. It can include concepts for advanced reactors.
Are they also focusing on big data? Okay.
Some big data as well.
Is there any way to submit a proposal on sensor for occupancy counting using machine learning?
I don't think that will fit under this goal. Bruce?
I would have to see it. It's hard to say. Yeah.
For NEET 2.3, what are the highest priority sensing needs?
I guess it will depend on the application. Bruce, do you have any feedback on that?
Sensors, I think that can be, deployed in situ in nuclear power plants that, for example, don't require power, can transmit wirelessly. Those would, from a nuclear power plant owner operator perspective, would be high priority because those are things that could be used immediately. Obviously, things that are qualified for the nuclear use environment would be high priority. So I think you have to go through the qualifications, the applications, and also look at the existing gaps in sensing technologies to identify what you think would be high priorities. I don't think that we have an A priority list of what we think are high priorities.
Are applications on wireless sensors encouraged?
If it applies to I guess if it supports what we're looking for, control and data analytics, I think so, because we're trying to avoid so much the wire, and so wireless communication will be good. We just have to see how it's applied.
Okay, those are all the questions we have. Thank you, Subel. Thank you, Bruce.
Thank you.
We are finishing out our day for day one of the CINR webinar. Tomorrow, we will resume at 10 o'clock a.m. Eastern Time. We will discuss the NSUF overview topics at that point in time. Thank you for attending today. You can submit any questions you have or additional technical questions you may have to nup@inl.gov, and we will respond to those as soon as we can.